Hello everyone, in this module we are going to learn how to create arrays in NumPy by different methods, and we are going to cover what is NumPy array, how we will create an array by using these methods. So before we will create an array, let us discuss about what is NumPy array. NumPy arrays are commonly used data structure in Python that store data as a grid or a matrix form. NumPy arrays are a bit like Python list but still very much different at the same time, because an array is a collection of homogeneous data types that are stored in a contiguous memory location. On the other hand, a list in Python is a collection of heterogeneous data type that is stored in non-contiguous memory location. So we will discuss another reason that NumPy arrays support arithmetic and other mathematical operations that run on each element of the array. For example, elements by element multiplication. NumPy array has the d-type attribute which specifies the data type of all the elements in the array. So if the array contains elements of different data types and all the elements are cast into a largest type, then this process is known as upcasting. Now we will learn how to create an array. So we can create an array in the following different ways. Let us list ways of creating NumPy arrays one by one. The first approach is using NumPy.array. Basically, NumPy arrays can be created very easily by passing a list to the function in NumPy.array function. Now we will discuss the syntax of np.array function. So NumPy.array is the function name, and within this function the very first parameter is object. This parameter indicates an array or it can be an object. The second one is d-type parameter. In case if this parameter is not given, then this type will be determined as the minimum type required. The third one parameter is copy. If the value of this parameter is set to true, then the object will be copied. The fourth one parameter is order. This parameter is used to specify the memory layout of the array. Now sub OK and ndim, these are the optional parameter. Mostly we cannot use these parameters while creating an array, but if you want to check the minimum number of dimension, then you can easily use ndim parameter in example. So let's see an example to better understanding the concept. Here I am using the Visual Code Studio. So here I have taken an example which first I have imported the NumPy library with alias name np. Then we have declared a variable that is product id and assigned the values returned by np.array function. So remember one thing, in the array function we have only passed the element, not axis. Lastly, we have tried to print the value of product id and check the dimension of array. As you can see in the output, the array has been shown and the dimension of array. Now we will learn the next method of array creation, that is np.arrange function. The NumPy arrange function returns evenly spaced numeric values within an interval that is stored as a NumPy array. Here is the syntax of NumPy.arrange function, and there are a set of parameters that enables you to specify the exact function. So NumPy.arrange is the function name, and the very first parameter is start. This parameter specifies the start of the interval, and the second parameter is stop. This parameter indicates the end of the interval, and third parameter is step. The step parameter specifies the spacing between values in the sequence. The next one parameter is d-type. The d-type parameter specifies the data type of the array. Now let's work through example how to use the arrange function while creating an array. So here I have taken an example which first I have imported the NumPy library with the alias name that is np. After this we have created a two-dimension array with NumPy.arrange function, and to create a two-dimension array we have to adjust with the NumPy.reshape method. NumPy.reshape method basically enables us to change the shape of a NumPy array, and in NumPy.arrange function we have set the numeric integer value that is 12. Along with we have set the reshape of an array in the order of rows and column. In the output the array has been shown and in the form of two-dimension array. Now we will learn the next method of array creation, that is np.linspace function. This function produces an evenly spaced observation within a defined interval, and it is quite similar to arrange function, and it is also used to create an NumPy array. So here is the syntax of the np.linspace function, and the very first parameter is start. This parameter indicates the start of the sequence, and by default it is considered as zeros. The next parameter is stop. This parameter specifies the endpoint of the sequence, and the third one parameter is num. Num indicates the number of elements to be generated between start and stop, and by default its value is 50. The next one parameter is endpoint. If it is true, then the value indicates the stopping value and it is included in the interval. The next parameter is restep and the value is false. The dtype parameter specifies the data type and axis will be the specify the dimension of an array. So let's see an example to better understanding the concept. Here I have taken an example which first I have imported a NumPy library with the alias name, that is NP. Then we have declared a variable that is array, and within this variable we have assigned the np.linspace function. In the linspace function we have passed only the elements and not axis. Lastly, we have tried to print the value of array. In the output, the array has been shown and it displays the number between 16 to 18. Now we will understand the next method of array creation, that is np.empty. This function is used to create an array without initializing or declaring the entries of given shape and dtype, and basically this function is used to enables the creation of array with a given shape. So here is the syntax of np.empty function. The very first parameter is shape. This parameter defines the shape of the empty array. The next parameter is dtype. The dtype parameter specifies the data type, and by default it takes float value. The next one parameter is order. This parameter is used to specify the memory layout of the array. Basically, this function returns the array of initialized data that have the shape, dtype and order defined in the function. Now let's work through example how to use the np.empty function while creating an array. Here I have taken an example and use the np.empty function for creating an array and pass the shape within this argument. Lastly, we have tried to print the value of array variable. Now we will learn the next method of array creation, that is np.zeros function. Basically this function is used to provide a array with given shape and dtype, and it will return the zero values in the form of array. Here is the syntax of np.zeros function. The very first parameter is shape. This parameter defines the shape of the zeros function. The second one parameter is the dtype. The dtype parameter specifies the data type of an output array. And the next one parameter is order. This parameter is used to specify the memory layout of the array. So let's see an example to better understanding the concept. Here I have taken an example which first I have imported a NumPy library with alias name np, and then we have declared a variable that is array and use the function np.zeros, and within this function we have assigned the numeric integer value that is 8. So once you will execute this code, the output displays the one dimension array and the array contains only 0 values. Now we will learn the next method of array creation, that is np.I function. Basically this function is used to create an array and it will return a 2-dimension array with one's value, and the values will be diagonally values and remaining elements will be zeros. So here is the syntax of np.I function. np.I is the function name and the very first parameter is capital N. It specifies the number of rows in the output, and the next parameter is capital M. This parameter indicates the number of columns and by default the value is none. The next parameter is k. It specifies the index of the upper and lower diagonal. The next parameter is dtype. By default it takes float value and it specifies the data type of the array. The next one parameter is order. This parameter specifies the memory layout of the array. Now let's work through example how to use the I function while creating an array. Here I have taken an example, and in this example I have used the np.I function, and within this function we have set the shape of an array. As you can see the output, it displays the 2-dimension array and the elements will be diagonally and rest elements will be the zeros. Now we will learn the next method of array creation, that is np.1 function. Basically this function returns a NumPy array with one's value, given data type, and to create a n-dimension array of one's value we have to pass the number of elements in shape argument. So here is the syntax of np.one's function. The very first parameter is shape. Shape parameter defines the shape of an array, and the next parameter is dtype. Dtype parameter defines the data type of an array. Now let's see an example to better understanding the concept of np.one function. In this example we have created a variable that is array, and within this array we have used the np.ones function and assigned the numeric integer value that is 7. Once you will execute this code, it will display the one dimension array and it contains only one's value. So in the next module we will learn the data type and attributes of NumPy.